Starting this month, you can access Google's Gemini programmatically through OpenAI's library. Seriously, Google has its own library because of course it does, but they've decided to let you use the OpenAI library instead, even though Google and OpenAI are direct competitors. Welcome to Tales from the Jar Side. My name is Ken Kousen. On Tales from the Jar Side, I try to give you expert advice on working with Java, Kotlin, Spring, AI, and related topics. Most relevant for this video is I don't work for any of those companies, so I can tell you what I really think. This time, we're talking about accessing one of the foundational AI models available, Google's Gemini, using a library from a different model, OpenAI, the owners of ChatGPT. I should note right away that OpenAI's API is already pretty popular. Mistral, the French company, provides its AI model through OpenAI's API already. And the Claude one, the one from Anthropic, is similar, if not exactly the same, and there's a couple of image generators that already use the OpenAI model. Here is an article at InfoQ that talks about Google debuting an OpenAI compatible API for Gemini. And the first paragraph basically has what you need to know. It says, in an effort to make it easier for developers who adopted OpenAI for their LLM-based solutions. So these are developers who already went with OpenAI. This is to make it easier for them to switch to Gemini. Google has launched a new endpoint. So there's a new RESTful endpoint for their web service for its Gemini API that allows developers to easily switch from one service to the other. The endpoint's still in beta and provides only partial coverage of the OpenAI capabilities. Let's take a look. Now they've got code in here, but in fact what it references is this blog post directly from Google. So this is from November 8th, 2024. Gemini is now accessible from the OpenAI library. And if I scroll down a bit, here is a Python example. And the first line tells you what you need to know, is that they're importing the OpenAI class from the OpenAI library, from their module. And then they instantiate it, and you see what they did differently. They changed the API key to Gemini's API key, that figures, and they changed the base URL to the one that goes to Google. So all they had to do was load a different API key and a different base URL, and then they have to pick the right model. Here they're picking Gemini 1.5 Flash. In a video I did a couple of weeks ago, I talked about the Perplexity AI API. They did something almost identical to this. They also used the OpenAI API with their own key and their own endpoint and their own models. Here we're seeing something very similar. Let me actually load this code into an IDE. Here I have the code loaded into PyCharm, the Python IDE from JetBrains. And the only thing I have different from what they had in their sample is I've imported the OS module, library, whatever, so that I didn't have to hard code my API key into the script. I'm getting it from an environment variable called Google AI API key, naturally enough. So here the messages I'm sending are, you are a helpful assistant as a system message, and explain to me how AI works as a user message. That's the example they were showing. Before I run it, I'll note the other thing I'm doing is taking advantage of the fact that AI tools tend to return a response in markdown format. So I'm going to save the output to a markdown file, and that way I can look at it directly. Let me run this. Okay, the first thing I notice is that it did in fact use the Gemini 1.5 Flash model because I printed that out. Also, it didn't print the usage tokens that I was expecting. So again, they are supporting some of the OpenAI API, but not everything. Now let's look at the actual output. And you can see here it says artificial intelligence is a broad field encompassing various techniques, blah, blah, blah. There's machine learning and deep learning and natural language processing and computer vision, expert systems, and so on. See why I saved it into a markdown file. You get this nice little preview. Now, if you are a Python person, you're good. You know what to do from now on, although I do want to investigate a little bit about the vision model too. But I'm not a Python person, I'm a Java person. Most of the code I work with is Java or at least JVM based. So it could be Kotlin, could be Groovy, could be whatever. And therefore, I need a way to incorporate these AI tools into that. In order to do that, I'm going to use one of the two major frameworks that is provided in the Java world for integrating AI tools. That would be LangChain for J and Spring AI. And let's take a look at both of them. Now, here I am in the documentation for LangChain for J. It's at docs.langchainforj.dev, and then you drill down in. And I went into the integrations for the language models, and you see there's a model for Anthropic, and there's the Google AI Gemini one. We'll come back to that. There's their Gemini one on their Vertex API on the cloud provider. Hugging Face, Mistral, Olama, and here's OpenAI. So let me take a look at OpenAI. And inside OpenAI, they say you add the dependency for OpenAI. They have a Spring Boot starter too, in case you wanted to work with that. You set up an API key. You create from the OpenAI chat model a builder, put in your API key and build it, and then you're ready to go. So let me look at the code now. Let's go directly into the OpenAI model and set it up to work with Gemini, of all things. So I do have a little enabled if environment variable annotation on here. This is a JUnit annotation that will skip this test if there's no environment variable for the Google AI API key. You do have to go to Google and get an API key after all. You're still using their model. So here I'm using the OpenAI chat model with its builder, accessing the Google AI API key from the environment variable, and I change the base URL and I put in the entire URL. We saw that in the Python code. That's the not just the base, but the extension and everything. We're going to have to talk about that when we get to Spring, but here I can put in the whole thing and it'll be fine. Then I'm picking the model to use, which will be Gemini 1.5 Flash. So if I want to access this now, I can call generate, explain to me how AI works, and let me run it, and we'll just see the output there. I'm not saving it to a file this time. I just want to see that I got an answer back, and it should give me the answer without a problem. And there it is. Artificial intelligence is a broad field, blah, blah, blah. And there's all the different pieces, just like before. And we're good. So again, all I had to do was use the Google API key, set the base URL to go to Google, pick a Google model, in this case Gemini 1.5 Flash, and everything worked just as you want. I also set it up just to prove that I could do a system message and a user message. Same basic thing, and this time I'll try to print out some of that additional metadata that comes out of this. And in this case, you could see the finish reason was stop, as it should be. No metadata. There's the answer. And at the bottom, again, they're not supplying the token usage. We don't know from the Google part what a number of input and output tokens they happen to use. Now, that's good, but let's take a look at the vision model, because there's a quirk here. Now this page is at Google. This is at ai.google.dev. It's part of their documentation. This is the page on OpenAI compatibility that's supposed to give us everything we need to know. And you see they're giving us that same Python script, of course. They have it in Node.js. They also show a REST API if you'd rather go that way. That's all fine. They also mention that they support a streaming model. I have no doubt about that. I don't feel any need to experiment with that one. And they support function calling, which is pretty good. I'll have to try that out. I haven't worked with it yet, but if it's supported, it should work through my frameworks as well. But the part I want to talk to you about now is the vision model. I'm going to put in an image, and it's going to give me a description of what's in that image or try to interpret something from it. Now, LangChain for J has that built into the OpenAI one without a problem. And in fact, let me show you that for the moment. To have an image for it to interpret, this is a picture I picked at random from Wikimedia. It's a publicly available image, and I've got a URL for it and everything, and this is an ibis fishing or something like that. So with LangChain for J, when you want to use the vision model, After you've created the model, you say generate, and you could put in a user message that includes the image content and text content. My text content is just going to be, what do you see? The image content has a from method, and in this case, it takes a string URL that needs to be a publicly available URL, at which point LangChain4j will download the image and go check it out. So let me run this one. And you see that I'll get back a response with content, and I can get the text out of it, and that should have the description of what's in the image. And sure enough, it says, this is again GPT-4o Mini. The image depicts a bird standing in shallow water. It has a long curved beak and a glossy plumage that appears dark with reddish tones. The bird is likely engaged in foraging, as indicated by the water droplets around its beak. Its posture suggests it is either looking for food or interacting with its environment. Okay, great. Let's see if we can do that with the Gemini model. So I have this test that I called Vision Chat from Remote Public URL. It's the same URL, it's the same test, basically. Let me comment out the disabled annotation here and try to run it. It's disabled for a reason, and you find out that reason right away. And what it says is OpenAI HTTP exception. The error code is a 400 invalid or unsupported file URL. In other words, it's not going to go and download an image from a public URL. Oh, okay. I mean, we saw that OpenAI will do that, but apparently Gemini will not. So the next thing I tried is I said, all right, let's download that image to a local temporary file and supply that as the URL. So let me clear that. Now, the way I did the download is I just used the standard HTTP client, and then I created a request and I made a temp file. And when I called send with the request, the of file method will save the response directly into that file. If it's not successful, I'll throw an exception. Otherwise, I'll return a string which has that URI in it. And hopefully now we're good. So let me try it from the local file. And once again, it says, nope, you're not doing that either. Invalid or unsupported file URI, which is really, that is a file URI. I'm not sure why it doesn't like that one. So when I went back to the documentation, when you look at this sample code that they have in Python here, you see that they have a function to encode the image. So the first step is to load a local file as an image, and then they did a base64 encoding of the file itself. So they read in the byte array locally and converted it to a base64 encoded string. Like, okay, that's the way they want to play it. That's fine. So this time I'm going to download the image as a base64 encoded string. So my method down here, instead of using of file to save the image directly to a file, I used a byte array, which will return a byte array. And then Java has a class called base64 that has an encoder built in, and I'll encode the byte array to a string. And now my image is in the form of a base64 encoded string. So let me try running this one. And that one worked. The response I get, this is a glossy ibis, Plegadis flacinellus, catching a small fish or aquatic insect. The image shows the bird with its long curved bill open, having just caught its prey. Water droplets are visible as the ibis pulls the small creature from the water. The background is blurred, focusing attention on the bird. Okay, so I got it to work, but I had to get the image bytes local and then go ahead and manually turn them into a base64 encoded string. But so be it. That's not an unreasonable demand. Google, when you use their direct API, wants you to upload images and video to their own file system and then work with their URIs that they supply you from that file system. I'm not going to demonstrate that now. Now, I want to show you one more thing before I go on to Spring AI, and that is this. Here is Google AI Gemini chat model, which is a dependency I simply add to LangChain4j. And these are all the same tests, and they have all the same responses and all the same limitations. I still can't do the local file URLs or the remote file URLs, but I can do the encoding, and everything works just fine. I'm not going to run its same basic output, but LangChain4j already supports that. Now let's look at Spring AI. Now, Spring AI has its documentation here, and I've already built a project that has the Spring AI dependency inside it. There is a starter for this. And in fact, I've even gone beyond that. I have gone down to the AI models here, and in fact, the chat models, and went for the OpenAI one. Now, you'll notice in this listing, by the way, there's a Google Vertex AI, but there's no regular Google AI like there was in LangChain, or LangChain for J, I should say. In other words, this may be the only way in Spring AI that I can work directly with Gemini if I don't want to go through the cloud provider. So, okay, hey, I've got a use case. But let's take a look at the OpenAI model here, and they say, all right, you've got to add the Spring Boot starter for the OpenAI model, and then there's a bunch of properties, and here's where life gets interesting. Let me skip down to the configuration properties, and you see here, there is the property for the base URL. Remember, we have to set that. And they also use a completions path, which is normally version 1 chat completions. We're going to have to modify that so that the concatenated URL is the one we want. And then we also have the OpenAI chat API key. Let's take a look at the code. Here you see in my application.properties file, I already have a Spring Boot project with the Spring AI dependency inside it and the OpenAI starter. Up here, commented out, is what I normally use for the OpenAI part. I set the API key to this environment variable, the OpenAI API key. I pick a model. I think the default is not this, so I set GPT-4o mini as my model, and I go from there. But now, and this feels so weird, I'm setting the OpenAI chat API key to the Google AI API key. And my model is Gemini 1.5 Flash. And here's the base URL. So it's just the part before the first major slash. And the completions path is the rest of the URL. So with that in mind, here I have a test. And this test, it worked before. I had this for a while with regular OpenAI. I didn't change anything in the code. All I did was change the properties, as we're going to see. So I auto wire in the OpenAI chat model, and then I'm going to use that model inside the create method of the chat client in order to send my message. Now, I can just go, hey, explain to me how AI works right inside the chat model, and it should use Gemini. Everything should be fine. Let's take a look. And yes, indeed, that's giving me all the information that we got before. Everything is working there as well. Here, I went into the newer API that lets you get into a bit more detail. So I set up a prompt and I put in the logger advisor so I could see the request and response come back. I made a user message that has text and a parameter so you can plug into the parameterized query. This is a neat little feature of Spring AI. Make the call, convert everything with the parameterized type reference. All this stuff. As I say, I was working with this with regular ChatGPT and it worked fine. And the question here is asking for 5 ice cream flavors, and there they are. So I set the property in their documentation that they say to use to start up the logging. And if I scroll down, now you will see that I'm using that simple logger advisor. And if I dig into this, you can see, yep, I am using Gemini 1.5 Flash with a temperature of 0.7 or whatever the defaults are. In other words, it's all working. And if I look at the bottom, you can see there's the response that came back. It's all working fine. Let me comment that back out because now I want to do the vision model and I don't want to log the base 64 encoded string. Now here, Spring AI demonstrates its value because before I had to download the image myself and do the base 64 encoding myself. With Spring AI, I can do text and I can add media, which takes a MIME type and a resource. So what I've done at the top here is I've added into my source main resources folder this image I called skynet.jpg, and it's a regular Spring Framework Core IO input stream resource. If you want to see that image, by the way, We are, after all, dealing with AI. So there it is. Now, when I go down to the vision model here, I don't have to do any of the downloading or anything like that myself. I just say, go read that image and pass it to them and see what we get back. And the model says the image shows a close-up of a head and upper torso of the Terminator-style cyborg with glowing red eyes, etc. In other words, it worked just fine. Okay, what have we learned? It looks like Google has decided to follow OpenAI's API. Now, we're in beta, and you could see that there are steps to go. There's a lot of things the OpenAI API can do that are not yet supported or not supported directly by the Gemini endpoint. The big question, of course, comes up in my mind is, why are they doing this? Right? What's the reasoning? Because after all, there is a Google API for that. Why not choose to use that? This may be part of the clue, although I admit this is pure speculation on my part, but hey, it's my video. Might as well rampantly claim things that I have no evidence for either way. So this was a survey that was posted very recently by Menlo Ventures, 2024 State of Generative AI in the Enterprise. They surveyed 600 U.S. enterprise IT decision makers to find out the, quote, winners and losers. This is as recent as I can get it. This section, LLM trends, multi-model strategies prevail as OpenAI cedes ground to Anthropic. Rather than relying on a single provider, enterprises have adopted a pragmatic, multimodal approach. Our research shows that organizations typically deploy 3 or more foundation models in their AI stacks, routing to different models depending on the use case or results. The strategy extends to open versus closed source debate. They do use the open source models as well, where preferences have remained stable despite heated industry discussions. Closed source solutions underpin the vast majority of usage with 81% market share, while open source alternatives led by Llama 3 from Meta are about 19%. So here is the figure I want to show you. Take a look at that. So this is year-over-year results. The faded one going into the bright orange one is a transition from 2023 to 2024. And you could see OpenAI, who had what you'd call a first mover advantage, has dropped considerably. The 50% down to 34%. And most of that went to Anthropic, using Claude, going from 12 all the way to 24. I have to say, for my experience, Claude is by far the best, but I'm mostly using it for code generation, and I really like it for that. Meta is there with the open source Llama 3 model at 16%, didn't really change. And there in a distant fourth is Google. Now, their enterprise penetration did improve. It went from 7% to 12%. But that's still fourth. It's not big. Mistral is one of the also-rans, and then there's just basically categories of other inside there. So is Google supporting the OpenAI API because they're saying the industry's adopting OpenAI? We can make it easy for people to switch to ours, and they'll also have their own API. So once they get the developers to go over, then maybe they will adopt Google's API and everything. Now, what does Gemini bring to the table? What does Google bring to the table that is unique to Google that makes it the AI of choice? It's really all about the context window. The context window is the number of tokens you could fit into a request. And for OpenAI, it's 128K. So 128,000 tokens in the context window for GPT-4o. Both the regular one and the mini one. Anthropic, Claude goes up to 200,000 tokens. So that's pretty good. Google lets you use, wait a minute, best Dr. Evil impression, 1 million tokens in the context window. Yeah, I know I couldn't do it. I'm sorry. And if you use Gemini 1.5 Pro instead of Gemini 1.5 Flash, it's 2 million tokens in the context window. So if you have to analyze video, really, images and would be one thing, but video would be another, then you really want Gemini, because it can handle many minutes worth of video and try to analyze that. And there's even demos on their website. So that might be the driving factor. But at the moment, it's not enough of a driving factor to get them beyond 12% market share and beyond fourth place in this battle of the major foundational models. Anyway, I hope you enjoyed that. I'm going to do additional videos on a variety of AI related and Java topics, so please subscribe and see you next time on Tales from the Jar Side. Take care.